Hello guys, we've run so far a thread and critical section. To protect the critical section, we use the critical section object in Windows operating system. And to safely apply critical section class, it's called mutex in C++, and we applied RAII for mutex. And the we jumped to standard C++ thread API. And when we first implemented our own game server, there are no standard thread API. So in this course, I will use Windows API because Windows socket function are more friendly with Windows API. I mean the Windows Thread API and Windows Event API. But later, maybe if we have time, we need to apply a standard C++ Thread API for our game server. Anyway, we need to understand this thing, and maybe in our implementation, we will not use Rockputty containers. But later, if you have time, you need to understand how can you use Rockputty containers for the game object, for the game servers. And then I covered how we implemented RAII style macros. Yes, and this type of macro can be frequently used when they're implementing standard C++ functions, or in a game engine like Near still uses this kind of technique. So today, next topic. So when starting thread, we need to consider two kind of synchronizations. So let's call this is thread 1, and yes, this is thread 2. Yes, first the synchronization is called critical section. Yes, let's assume this block is shared between two threads, and if in the block they access the same location of memory, and generally it's a global variable or a global object. So let's assume this is shared. And without protection, both threads access this shared memory simultaneously. It's very dangerous. So this kind of code block is called critical section. Okay, so there must be a way to protect this critical section. And in Windows operating system, they defined critical section structure. It's called critical section structure. And the standard term for critical section structure is called mutex. So when you cover C++ standard thread API, instead of critical section, we used mutex. So mutex lock and mutex unlock protect the critical section. So the code itself is called critical section, and the standard term to protect the critical section is called mutex. Yes, this is the first type of synchronization, but there are second type of synchronizations. For example, when thread 1 is here and thread 2 is here, let's assume when thread 1 is done to here and also thread 2 do something at the same time simultaneously, but to continue thread 1 to continue its execution, yes, for example, it needs to wait some data processing of thread 2. So when it's done here, it notifies thread 1, I'm done, so you can use my data. So in this case, thread 1 must wait here, and then when it's done, continue execution here from here. So in this type of synchronization, we need to a way to notify execution, the completion of task inside the thread 2, and in thread 1, there must be a way to wait some task completion from thread 2. So for this purpose, we can use event object. It's called event object in Windows operating system. But the standard term for event object, as we already learned in C++ standard thread API, it's called conditional variable. Conditional variable. So you need to understand in mutex in Windows platform, it must be implemented with a critical section. And for event object is Windows object, Windows operating system object. But standard term for event object is a conditional variable. And the critical section and event object is more where work with WinSock API. So in this our game project, we will use Windows critical section and Windows event object. And when using Windows event object, if thread 2 finished its processing its signal to event object, that means that I'm done with my task. So if someone wait my task, you can use my data. So it's called signaling. And then in T1, wait that signal. And if thread 2 signal this object, it wake up the waiting signal. So there must be event object and a function which is signal the event object, and there must be a function which wait the event object signaling. So this is a second type of synchronization. So in this video, let's run how can you synchronize between thread. And if you use this kind of event object, there is some kind of problem, and it's a well-known problem, and it's called deadlock. And to understand the deadlock, they generally explain deadlock it is dynamic philosopher problems. So let's assume there are 5 philosophers are here, and they share their left fork and right knife, or 2 forks. And to eat their dinner, they need to pick both fork, and on his left hand, on his right hand, they must use 2 fork. So let's imagine this kind of scenario. All the 5 philosophers try to take his left fork, and then if it's available, it takes his left fork, and try to get his right fork. And if all the philosophers at the same time try to pick their left fork, yes, it works. This Pascal gets his left fork. Maybe Newton also picks left fork. Yes, it works. And then all the philosophers try to take his right fork, but any fork is available for all the philosophers. So if there is no rule, all the philosophers need to wait. So maybe they starve forever. So it's called starvation, and sometimes it's called deadlock. So how can you solve this problem? So to solve this kind of problem, we need to define some rules. For example, if philosopher get his left fork and then try to get the right fork, if right fork is not available, he may put down his left fork. Or some even philosopher first try to get left fork, and other position philosopher try to get his fork at right position. Anyway, if there is no this rule, there may be infinite waiting, and that's called the deadlock. So when working with the event, maybe there may be a deadlock. So what is Windows event object? So an event object is a synchronization object whose state can be explicitly set to signaled by calling setEvent function, and it's called the signaled state. And Palo diagram shows how event object works. So let's assume thread 1, thread 2 run simultaneously, and thread 1 performs some handshaking with the servers. And while thread 1 doing this task, thread 2 start to loading XML data from here. But when thread 1 finished perform of handshaking with the server, thread 1 can try to process data which is loaded from thread 2. But let's assume this data is not loaded completely. In that case, thread 1 need to wait from here. So if the data is loaded, data loading is finished, it signal via event, and then thread 1 need to wait some condition. So when it's signaled, it start to processing the loaded data with this one. So if you use two-threaded for this kind of work, user may fear there is no loading time because while they processing the server handshaking task, data is loaded in background thread. So this is very common scenario. How can you use the event object to synchronize between thread? But if you use event object, there may be a starvation. So this shows there may be a deadlock. So this diagram shows what deadlock is. So let's assume both process P1, P2 try to process resource 1 and resource 2. And let's assume process P1 already occupied, already acquired resource 2. So resource 2 belongs to P1. And resource 1 already belongs to P2. So this resource 1 is already assigned to P2. So try to use R1. P1 need to wait. The P2 finishes with R1. And P2 also try to use R2. But to use R2, P2 need to wait P1's finish. But R2 is already assigned to P1. R1 is already assigned to P2. So both P1 and P2 wait infinitely each other. P1 wait R1 is finished. P2 wait R2 is finished. So if there is no rule, P1 and P2 wait infinitely. So this is called deadlock. So when you're using event object, yes, there may be a deadlock, and there are some deadlock avoidance algorithms. So when you're using event object, we need to carefully use the event object. So for example, when you're using critical section, there is no deadlock because in the thread, the critical section is always wrapped by mutex object. So mutex lock and unlock will be called in the same thread. But in this kind of synchronization, in a thread calls signal and the other thread calls wait. So because there are more than two threads are related to each other, there may be a deadlock. So I prepared some small example which shows what deadlock is and how can it resolve the deadlock situations. So you need to download sources from github.com. If you visit github.com GP101, we already downloaded the source called the Dcon server. And if you download the Dcon server, there are some projects from chapter 1 to chapter 5. And under prerequisite board, there are console project and Win32 thread and Win32 thread 2. So you need to open this Win32 thread. And I already downloaded and it's here. So under the prerequisite folder, open this solution file with Visual Studio 2017 or 19. And this project is made with 2017, so I'll use 2017. And I already opened that project. And here, if you expand second project, select the second project and set as a starter project. And then if you expand, there you can see Win32 thread. And this shows the basic thread usage. And I want to show you basic examples of printing numbers with the two thread. So after expanding reference files, so open this one and copy entire sources, Control C, Control A, Control C, and then paste it into Win32 thread. Control A and Control V. And this shows how can you use event object. So at top, I declare the two event handler GH events, and we use these two events for thread 1 and thread 2, and they are shared variable G underscore value. Because it's shared between thread, we need to use critical section, but in this example, we don't need to use them because the logic guarantees that G underscore value is always executed at one thread at a specific time. And in main, you can see some, so let's remove unnecessary comment or error handling code for simplicity. Inside for statement, we need to, in final result, there must be this kind of error handling code, but for now, let's remove it for simplicity. So here, create events, two events, and create thread, returns thread ID via alpha parameters, and also return thread handler. And also I will remove this one. And wait 2 seconds and start job. Yes, G underscore value will be increased by 1 up to 10. It tries to print this value. After printing value, G underscore value will be increased by 1. And here you can see wait for single object. Okay, and this is waiting signal event waiting functions. Okay, and here you can see set event functions, and this is signaling functions. So when you created the event by a set event call, you can signal that event, and by calling wait for single object, you can wait a event object. So here, as you can see in main thread, when they signaling event, second event is passed as parameter, but when it waiting, first event is used here. So, and then when you're done, you need to close all event handler by calling close handler. And thread proc is the second thread, and this thread proc is called here. When you creating thread proc is a thread callback function for second thread. So in the thread proc, yes, to remove warning, I put here, and in the thread proc function, yes. So you need to change this 9 to 10 because in main thread, it iterate up to 10. Okay, and yes, do same thing. So copy wait for single object and remove and paste it into here. So same logic. For example, here wait and then do task and set event. So wait, do task and set event. Wait, do task and set event. And then try to build. Yes, there's no errors. And I will explaining how can I use Windows event. So first we need to understand Windows event. And the standard implementation for Windows event is a conditional variable in C++ standard thread API. Event object is a synchronization object. Because it must be shared between thread, so generally it must be declared as a global variable, and whose state can be explicitly set to signaled by calling set event functions. So it's called the signaled state. And there are two types of events. It's a manual reset event and auto reset event. In manual reset event, when you call the set event, to reset that event, you must call reset event function. In auto reset event, if you call set event function, and in other thread, if they call wait for single object, it will be automatically reset when someone processed by calling wait for single or wait for multiple object. So generally, we can use auto reset event. So if there is an event object, we can signal that event object by calling set event. So this is a event object, and in some thread, if they call set event, it signals this event. And in other thread, if they are waiting this event will be signaled or not, they need to call some wait function. So to signal the event, we can call set event function. To wait this event, we need to call wait for single object or wait for multiple object. So if we need to only wait for single object, you can call wait for single object too. But if you need to wait multiple object, you must call wait for multiple objects. So when you're using wait for multiple object, first parameter is the number of event, and second parameter is a starting address of event array. And if you use wait for single object, you just specify one event handler. And when you're calling wait for multiple object, you need to prepare event handler array, one-dimensional array, and here you must specify starting address of that array. So there is event signaling. You can call set event to wait. You can call wait for multiple object and wait for single object. And wait for multiple object or single object returns wait object 0 or other values. So generally, when they return the wait object 0, it means that someone signaled that event. But in some cases, even they didn't return wait object 0, yeah, it's treated as normal cases. And that kind of thing will be explained in this course when you working with the IOCP completion port. So let's try to load this project. It shows how can you use event and which causes the deadlock and how can you solve a deadlock problem.